Okay, so let's use an example to understand the relationship between short and long run cost curves. So let's say I want to start a food truck business. So I'll need a food truck for that. And to make sandwiches to sell in the food truck, I need laborers, I need bread and vegetables and condiments and everything. Now, in this scenario, I can maybe put in enough money and buy my first food truck, but I can't buy successive food trucks very quickly, right? I will probably need to spend about a year or so in the business to earn enough money to buy my second food truck. So if I were to treat my food truck as my capital input is now relatively fixed for a period of time. So if my period of time under interest is say 1 year, in that period the capital input is fixed, but I can easily vary the other inputs like laborers, bread and sauces and so on. Now, this story in year one forms my short run period number one. Now, suppose I've been in business for a year and now I've made enough money and my business is doing really well and I want to expand my business. Now, the best way to do that is to get an extra food truck. And now I have the money to do it. So I can purchase an extra food truck and also hire additional people to man the second food truck. Now, we now have increased our capital input, but remember that the capital was sort of fixed in the first year. And only after a period of time elapsed, I could buy the second unit of capital. Now, if I want to increase my capital further, if I want to get a third food truck, I can't do it immediately. I'll have to wait for another year, make enough money over and above the cost of running two food trucks. And only when I've saved enough can I get a third food truck. And by the time I get there, it'll probably be year 3 or 4. So now we're talking about a second short run period where I've now ramped up my capital to two food trucks, but I can't increase it any further. I'm stuck at two food trucks until a certain period of time elapses. So what's the scenario here? Short run one, I'm stuck with one. I have one truck, some laborers. Then I move to short run scenario two, where I've increased capital stock, but I can't move it any further. I wait for short run period three to turn up to increase my capital stock and so on. Now, in this way, if you just put together a series of these short run periods, what am I looking at? I'm looking then at the long run period. So essentially, I'm saying that the long run period is made up of a series of short run periods strung together. So in this food truck example, I could go with 3 trucks, and then in year 4, I can get the 4th one, and then the 5th one, and so on and so forth. So over a period of time, say in the long run of 5 years, I would have actually gone from nothing to 5 trucks. So in the long run, my capital is variable. Whereas in the short run, given a period of time, I have to use the trucks that I have, and I have to wait for some time for the capital to be able to change that again. So keep this example in mind and focus on the slides that are coming up. So we're going to draw a series of short-run cost curves depicting this scenario for every short-run period. And we'll see how we go from there to the long-run cost curve. Now, if you notice in the chart, in the graph that you see in the slides, let me just zoom that in a little bit for you. We're looking at, focus on the first panel. And we have a cost curve, okay, which says SC bracketal K0. So this is a cost curve for time period 0, where the capital stock is fixed at K0. Now, if you notice, this has sort of a cubic shape. So the cost curve increases slowly initially, and then it starts taking a convex turn. So we don't like this convex part of the curve because that means costs are increasing rapidly. So we want to stop our production just before that turn happens. So Q naught seems to be like an optimal amount of output that I can produce with K naught levels of capital stock. So that's this point. Let's get to the next time period. So we're able to increase our capital stock in the next time period. So I have a new cost function that is now associated with a slightly higher level of capital. This function again has a cubic shape. And just at this point, I found the sweet spot with that level of capital by producing Q1. If I produce any more output, costs will increase at an increasing rate, and I don't like that. Switch to time period, the next time period. So where we have a higher level of capital stock and a cost function associated with that. And the sweet spot is right there, producing Q2 levels of output. So what have I done? I have traced cost functions over different short-run periods, each with higher levels of capital progressively, and therefore higher levels of costs, and each with higher levels of capital giving me better output. And I've traced all of these points where I've identified just the right amount of capital that I need to produce a certain output. So with capital level K0, I know my optimal output is Q0. With K1, I know it's Q1. With K2, I know it's Q2. Think of it another way. If my goal were to produce Q0 levels of output, having just K0 capital stock gives me the least cost. Because if I were to use higher levels of capital like K1 or K2, my costs are way higher. So for Q0 output, K0 is the right capital stock. Similarly for Q1, K1 is the right capital stock because K2 will be too expensive. For Q2, K2 is the right capital stock. So in this manner, once you have identified just the right amount of capital that will work well in that short-run period for a target level of output, if you just join all of those optimal points together, what you get is your long-run cost curve. That is all there is. So your long-run cost curve is essentially something that envelopes optimal points in your short-run cost curves. So in the top panel, we have a scenario where in the long run, you have constant returns to scale, so a linear cost function. In the panel below, I think it's a more realistic case. We have a long run cost curve, which takes on a nice cubic shape. So it increases slowly first and then starts increasing quickly. So this is essentially what your long run cost function is all about. So if you notice, at every point on your long run cost function, all points on your long run cost function will actually lie below the short run cost functions, except at those points where you'll have an equality, because the points where it's equal or tangential actually represent, you're producing that level of output using a capital stock that is best suited for that level of output. So for 100 sandwiches, maybe one truck is the right, is the best. Maybe when I get to 200, I need 2 trucks. 300, I may need 3 trucks, and that's the most optimal combination. So this is the intuition behind short and long run cost curves. So your long run costs are always lesser than or equal to your short run costs. And they're pretty much an envelope. You just straddle the short run optimal points as to construct your long run cost curve. So it's pretty much an envelope. Now, you've seen the first 2 panels, so I'm going to skip that. Right. So we can very conveniently go from short run costs to long run cost curves. Well, the long run cost curve, if you noticed, all the points there solve these optimal points. They have to be on a respective short run cost function also. So a long run cost curve will satisfy the particular short run cost curve, which depends on the input prices, the target level of output, and the particular level of capital stock that is held fixed in that short run. So my long run cost curves will touch through all of these short run points, so they have to satisfy this equation. And in order to identify that optimal level of capital stock, we have to solve a particular equation. We just have to find that level of capital, which is the sweet spot for producing a certain level of output. So if you were to focus your attention here, you could think about it in a couple of different ways. Now, if for a target level of output for Q0, okay, so if I fix my output level here, my lowest cost actually comes from this point. So that should be my capital stock. I shouldn't go for K1 or K2 because those are not the least cost options I can find. So I want to find K such that it minimizes the short run cost function for that target level of output. Okay, so this may be a little challenging to understand initially, so take some time to absorb this. We're now going to see an example with the Cobb-Douglas function, a traditional function that is given to us, and we are told that capital is fixed at k equals k1. So we rewrite our production function to reflect the short-run scenario by replacing k with k1. Now, I can now go ahead and write the short-run cost function also. It'll be vk1 plus w times L. And if I can just rewrite my production function where L is on one side and everything else is on the other. So I have my short-run cost function. Now to get the long-run costs, all I have to do is I have to choose that particular level of capital, K1, which will minimize my short-run cost function. And we're going to only be focusing on, if you take a derivative of SC with respect to K1, this is this is the result you're getting. And if you solve this equation for K1, you can find the optimal level of capital K1, which will minimize my short-run costs. And that is contingent on the level of output. So for whatever level of output you decide, you can find K1 that optimizes my short-run costs. And once I know that K1, if I just plug this back into my actual cost function, the result that I get is my long-run cost function. So this is how, whenever you're given a short-run production function and cost function, this is how you can go back and recover your long-run cost functions. So if we, just by plugging in some numbers for alpha, beta, v, and w, we have our long and short-run cost functions. So C is equal to 12Q actually comes from an earlier example that we did just a few slides ago. And we also have a short-run cost function. Okay, so we've identified our K1 is actually 80 in this case. So we've gone ahead and solved it. Now for different values of Q, you can see the long and short-run costs. Notice that for every level of output, your long-run costs are lesser than short-run. Okay, 360 is lesser than 375 and so on, except for that particular level of output where they are the same. So if your target level of output is 40, K equals 80 is your optimal level of capital stock. That's what this means, because this is capturing that point of tangency between your long and short-run cost curves. So except when, this should be Q equals 40, everywhere else your short-run costs will exceed long-run costs. Now, there's also another very famous, another chart we tend to see very often depicting this relationship between short and long-run costs. Now, I told you that the long-run cost is just made up of a series of short-run costs. And we saw a diagram where from the total cost curves, we could get the we could go from short to long term. Now, we're just going to show a similar thing using the AC and MC curves. Now, this curve that you see here is my average cost curve in the first time period, okay, with K0 levels of capital. And the corresponding marginal cost is given by this function. Now, let me just get a different color. SACK1 is the short-run average cost for the second time period and the corresponding marginal cost function. This is the average cost for the third time period with a higher level of capital and the corresponding marginal cost function. Now, my average cost function, right? Sorry, my long-run average cost is just going to identify those points where the capital stock is just enough to produce certain levels of output as predetermined. So if I want to produce Q0 levels of output, then this is the corresponding average cost is given by that point with capital stock K0. For Q1 levels of output, corresponding average cost is right here at K1 levels of capital. To produce Q2 of output, corresponding average cost is here with K2 stock of capital. So this way, I've identified the locus of all my average costs with different levels of capital. And then I'm just going to connect all of these through. And the locus of those points gives me my long run average cost curve. And you'll notice that at just this point, the average long run cost curve is at its minimum right there. And that also happens to be the lowest point in the average cost curve associated with K1 levels of capital. What this means is that the long run is made up of a series of short runs, but where we'll decide to produce in the long run, it naturally makes sense for us to pick this point here, right? The lowest part of my long run average cost curve is where I'm the most efficient. So that point is actually called the economies of scale, minimum economies of scale point. So as a food truck owner, I'll decide to, operate in the long run at this level of output. And that level of output will actually coincide with a particular level of capital stock that happened to be the scenario in one of the short-term periods. So for instance, if I decide that my optimal food trucks to manage are 3 food trucks, and 3 food trucks were, that was my scenario when I was in, I think, the 3rd or the 4th year, that optimal point in one of those short-term periods happens to be my long-run optimal point as well. So that's what this diagram indicates. So, okay. And then this table just follows through from the previous example. And notice that at Q is equal to 40, you have all of these points being very nice and tangential to each other. So this point where your long run AC equals long run MC equals AC and MC for a particular short run period. So that's what this table indicates. And just a few practical examples of where there'll be fixed short run costs. So whenever there is any input which is not very movable in the short run, or which takes a lot more effort to produce, the first copy, if it takes a lot more effort to produce, those are cases where we have fixed costs in the short run. So, and you will also have fixed costs in other huge enterprises like an electricity grid or a landline telephone connection and so on. So that's been a really long video, and my apologies for this. With that, we wrap up the costs chapter. Thank you and happy learning.